The observable universe is the part of the universe that we can actually see and study using telescopes and other scientific tools. This part includes everything from nearby stars and planets to the farthest galaxies we can detect. However, our ability to observe the universe has a limit. This is because light, the main source of information about distant objects, travels at a certain speed. Since light does not move instantly but takes time to travel across space, we are only able to see things whose light has had enough time to reach us. That means we are looking at the past whenever we look far into the farther something is, the older the light we are seeing. Because of this, we cannot directly observe events or objects that are too far away or that occurred too long ago in the early history of the universe. Scientists estimate that the diameter of the observable universe is about 93 billion light-year. That may seem surprising when compared to the estimated age of the universe, which is around 13.8 billion years. Wonder how the observable universe can be larger than the age of the universe in light years. The answer lies in the fact that the universe has been expanding ever since the Big Bang. Itself is stretching, causing galaxies and other objects to move farther away from us over time. So the light we see today from very distant galaxies was actually emitted billions of years ago. And during that time, those objects have moved even farther away because of the ongoing expansion of the universe. The result, the area we are able to observe, has grown larger than we might expect, just based on the age of the universe alone. Even though we have discovered a great deal about the cosmos, there is still so much we don't know. The observable universe is incredibly vast and full of mysteries, and new discoveries are being made all the time. One of the major tools helping us make those discoveries is the James Webb Space Telescope, developed by NASA with the help of other space agencies. It is the most powerful space telescope ever launched and has already provided us with stunning images and important scientific data. Through this and other instruments, scientists are learning more and more about how the universe is structured, what it's made of, and how it has changed over time. Using telescopes like the James Webb, researchers are also uncovering more about the events that took place shortly after the universe began, helping us understand where we came from and where we might be going. NASA recently announced that the James Webb Space Telescope has made contact with distant regions of the observable universe that we had never seen before. These areas are located extremely far away, so far that their light began traveling toward us nearly 13.88 billion years ago, just after the Big Bang occurred. By capturing light from these regions, the telescope allows us to observe galaxies as they were during the earlier stages of the universe's development. This is possible because as the universe expands, the light from distant galaxies is stretched into longer wavelengths, which shift it into the infrared part of the spectrum. The James Webb Telescope is specially designed to detect this type of light, allowing us to look further back in time than ever before. These observations help scientists understand how galaxies and stars began to form and evolve. In fact, data from the telescope has revealed that many galaxies were already forming stars at an incredibly fast rate when the universe was still very young. These discoveries lead to deeper questions about the universe and our place in it. For centuries, people have wondered whether we are alone in the cosmos. The more we learn about the vast number of galaxies and stars in the observable universe, the more we begin to think that there may be countless other planets, possibly even other forms of life somewhere out there. If there are so many galaxies we can see, then there could be even more in the parts of the universe we cannot see. unobservable universe. The idea that there could be millions or even billions of other galaxies beyond our reaches, both mind-blowing and exciting, sparks our imagination and encourages us to keep asking questions. The search for life beyond Earth has also been supported by discoveries of planets outside our solar system called exoplanets. Scientists have found thousands of these exoplanets using techniques like the transit method, where they observe a planet passing in front of its star, and the radial velocity method, which detects tiny movements in a star caused by the gravity of orbiting planets. Some of these exoplanets are located in what scientists call the habitable zone, meaning they are at the right distance from their stars to potentially support liquid water and possibly life. An exoplanet that has received a lot of attention is called WASP 96b. This planet lies far outside our solar system. By analyzing the light from this planet using the James Webb Space Telescope, scientists were able to detect the presence of water molecules in its atmosphere. Even more surprising was the discovery of clouds and haze in the atmosphere, features that were not expected on this kind of planet. The findings suggest that there may be many other planets in the universe with similar characteristics, and perhaps some of them could host life. While we have not yet found direct evidence of extraterrestrial beings, the discovery of water and other signs of habitable conditions increases the possibility that life may exist elsewhere in the universe. All of this leads to even more complex questions, such as whether our universe is the only one. This is where the concept of the multiverse comes in. The multiverse is a theoretical idea that suggests there may be many different universes beyond our own. These other universes could have different laws of physics, different types of matter, or even different versions of ourselves. The idea of the multiverse is often discussed in the field of quantum physics, which studies the behavior of the smallest particles in nature, like atoms and electrons. Some scientists believe that when a quantum event occurs, all possible outcomes actually happen, but in separate, parallel universes. This idea is known as the many worlds interpretation. However, it's important to remember that the multiverse is still just a theory. There is no solid evidence yet to prove it exists. Some scientists find the idea useful for explaining things that can't be explained by a single universe, while others remain skeptical and argue that the theory is too speculative. Just like the famous thought experiment known as Schrödinger's cat, or the mysteries of dark matter and dark energy, the multiverse is a concept that fascinates both scientists and the public. It pushes the boundaries of what we know and challenges us to explore beyond our current understanding. Another strange and lesser-known concept is something called dark flow. This idea came up in 2008 when scientists noticed that some clusters of galaxies appeared to be moving in a specific direction faster than expected. Motion of galaxy clusters should be explained by the known distribution of matter in the universe. But in this case, the movement seemed to be influenced by something else, possibly something located outside the observable universe. Scientists began to wonder if some unseen force or structure, such as a large amount of dark matter or dark energy, might be pulling these galaxies in a certain direction. This unexplained motion was given the name dark flow. However, dark flow remains a controversial topic. Some studies have supported its existence and suggested that a massive object or structure could be causing it. Other studies, though, have not been able to confirm the phenomenon. Some researchers think that the data might be flawed, or that the motion of the galaxies could be due to other reasons, such as measurement errors or natural variations. As of now, the scientific community has not reached an agreement on whether dark flow is real. Research and better data are needed to understand this mysterious effect. If dark flow does exist, it could point to something very large and unknown lying beyond the observable universe, something that is pulling on galaxies and affecting their movement. In the end, all of these topics, the observable universe, exoplanets, possible extraterrestrial life, the multiverse, and dark flow, remind us of how little we truly know about the cosmos. They challenge our current knowledge and invite us to keep exploring. Every new discovery opens up even more questions. The universe is vast, complex, and beautiful. And the more we learn, the more we realize how much there still is to understand. Do you think about all of this? Your thoughts in the comments. And don't forget to like this video, subscribe to our channel, and turn on the notification bell so you don't miss our next exploration of the universe.